Hello friends, this video on periodic classification of elements part 11 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 10. Which element has two cells both of which are filled with electrons? That's the first question. Then I have second, third, fourth and fifth question. To answer all this, let's take the first question. Two shells both of which are filled with electrons. That means it has something 2 and 8 is the electronic configuration, right? Because there are two shells and both are filled. 2 8 plus 8 is 10. So atomic number of 10 is neon. So this neon is my answer. Electronic configuration of 282, that is atomic number of 2 plus 8 plus 2 is 12. Atomic number 12 is magnesium. So magnesium is my answer. A total of 3 shells with 4 electrons in its valence shell. So my 3 cells and the 4 in the valence one. So 284. 284 is 2 plus 8, 10 plus 4, 14. 14 is silicon. So this guy is silicon. 2 cells with 3 in the valence electron, that is 2, 3 is my electronic configuration. 2 plus 3 is 5. 5 is this guy, boron. So boron is my answer. Twice as many electrons in the second cell as the first cell. First cell will have to be filled, right, to go to the second cell. So first cell will have 2 and the second will have 4 because twice the element in the second cell as in the first cell. So 2 plus 4 is 6. 6 is my carbon. This guy is carbon. So if you see, very easy to find the elements if I know some property of the element and I have the periodic table. What properties do all the elements in same column of the periodic table as boron have in common? So I have this boron. I'm asked that all these which have same column correct. So if you see, for all these, my valency is 3. In fact, valence electron is also 3. V electron. What properties do I have all the elements in the same column as fluorine come? So if you see the fluorine one, for all these, my valence electron is 7, right? All these are 7. You see, fluorine is 2, 7, 9. This guy is 2, 8, 7. Each and every element in these group has valence electron of 7 and valency of 1. This is the common thing they have. An atom has the electronic configuration of 287. What is the atomic number? So atomic number, you add these two, all these values, so you get 17. So 17 is my atomic number. To which of the following elements would it be chemically similar? The first guy is N7, right? So this becomes 25. For this electronic configuration will be 27. This is 15, so this becomes 285, right? This will become 288. Now I have 7 in the valence electron. So I am looking for 7 in the valence electron. That is, I am looking for this guy F. So my F9 is the answer. F9 will be chemically similar to this particular atom because both have similar number of atoms in the valence shell. So the position of 3 elements A, B, C in the periodic table are given below. They are group 16, group 17. State whether A is a metal or non-metal. So you can see that group 17 are all non-metals, right? So A is a non-metal. That is confirmed. A is non-metal. Second is C is more reactive or less reactive than A. So if you see C and B, C and A if you have to compare, right? C and A. C is bigger than A and they are non-metal. So as told, the non-metallic character decreases, right? So C is less reactive. C is more reactive state, whether C is more reactive than, so C is less reactive actually. C is less reactive. Correct? Why? Because we go down, the size of atom increases, the power of neutron to, or the power of nucleus to attract electron decreases, and it will not be able to attract electrons, and thus it will be less metal, non-metallic. Will C be larger or smaller than B? Compare C and B. C has to be smaller because the number of shells are same, but if you go from here to here, the proton becomes powerful as compared to B, right? And then it will attract electrons more if you compare to B, and thus the size will decrease. So you can see that C is smaller than B. Correct. What type of ions, cations or anions, will be formed by A? Since A is a non-metal, A will accept electron and A will become A minus. Correct? And A minus is nothing but an ion. Because I told that an ion is a negative charge. Right? A negative is an ion. So the A negative is an ion. Correct? So this guy is a non-metal because in group 17, C is less reactive because you go down, the atom size increase and the power of C to attract electron decreases. C is smaller than B or what? Yeah, C is smaller because the shells are same, and if you compare to B, C has more power to attract electron and the size will shrink. Since A is a non-metal, it will gain electron, becomes A minus, and that is an ion. Nitrogen, atomic number 7, and phosphorus, atomic number 15, that is, this guy is 25, this guy is 285, belongs to group 15 of the periodic table. Write the electronic configuration of these two elements. Which of these will be more electronegative pi? So electronic configuration I wrote, this guy is 25 and this guy is 285. Now if you see, this guy has got extra shell. So if we compare nitrogen and phosphorus, phosphorus is bigger, right, and got extra shell, right? Nitrogen is smaller and got only 2 cells. Correct. Now this, since the atom size has increased, the force between this guy and this guy is decreased. So this guy is weaker. Right, the atom of the nuclei of this is weaker to attract electron, and this guy can attract electron easily. So you can attract electron easily. This guy is more electronic. If I can say that my nitrogen is more electronegative. Why? Because the nitrogen atom is small and it can attract electron easily as compared to phosphorus atom. How does the electronic configuration of an atom relates to its position in the modern periodic table? So if we have seen that we have something called periods and we have groups, right? So first thing is, in a group, all elements have same valence electron in a group. That is one thing. All the elements in a group have same valence electron. If we talk about periods, right? So there's a consecutive increase in atomic number. So if you see, if you talk about periods, there's a consecutive increase in atomic number if you go from here to here. So if you see in both the cases, this electronic configuration matters. Correct? And they have similar electronic configuration. So based on electronic configuration, you can actually tell the position of a electron. For example, it is 282. I can tell that this guy is first, second, third period and group 13. First, second, and then you have 13 group, right? If I have something called 2-1, I can say that this guy is in first group and first, second period. Just by looking at the electronic configuration, I can tell where the element lies. So the question says calcium atomic number 20 is surrounded by elements atomic number 12, 9, 21, 38. Each of these have similar properties as calcium. So we have to find the electronic configuration. So calcium is what? Calcium is 2882. Correct. Now we'll see that this guy is 12. So 12 becomes 282. So if you see, the number matches. Thus I can say that this guy resembles property of calcium. So take this guy 19, this is 2881, doesn't match, right? Similarly, if you take 21, that becomes 2818 and 3, doesn't match. So if you see, nothing matches except this guy. Correct. So we can say that this guy matches the property of calcium because they have same number of valence electrons. We'll compare the Mendeleev's and modern periodic table. So if you see, here's a comparison. In this case, Mendeleev 1, elements are arranged on the basis of atomic mass. This here, it is arranged on the basis of atomic number. There are 7 groups and 6 periods only. There are 18 groups and 7 periods. Elements with similar properties are placed in a group, and here elements with same valence electrons are placed in a group. Please note there's a difference here. Position of hydrogen could not be explained in this case. Position of hydrogen is explained. There's a isotopes confusion here. There's no confusion of isotopes. That's the difference. Let's do a recap. Elements are classified on the basis of similarity in the property. Daubernier explained grouped the elements into triads and Newlands into laws of octaves. The Mendeleev arranged the elements in the order of increasing atomic masses and also based on the chemical property. He predicted the existence of some element which was not even there that time. There were some anomalies in the basis of ordering of atomic masses which could be removed when Moseley proposed this atomic number. And in modern periodic table, we have 18 vertical columns and 7 horizontal rows called periods. And elements thus arranged shows periodicity of properties including atomic size, valency, combining capacity, metallic, non-metallic character, all these things. It shows the periodicity in the periodic table. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.